In this session, we do solve some numerical problems in complex numbers. The very first question, if Z1, Z2, Z3 and Z4 be the consecutive vertices of a square, then Z1 square plus Z2 square plus Z3 square plus Z4 square is equal to. First option, Z1, Z2 plus Z2, Z3 plus Z3, Z4 plus Z4, Z1. Second option, option B is Z1, Z2, Z1, Z3 plus Z1, Z4 plus Z2, Z3 plus Z2, Z4 plus Z3, Z4. Option C, 0. Option D, none of the above. Let us see which option is the right option. First of all, what are Z1, Z2, Z3, Z4? They are the vertices of a square. They are the vertices of a square. As it is a square, we see that all the sides are equal. That is, mod Z2 minus Z1 is equal to mod Z3 minus Z2 is equal to mod Z4 minus Z3 is equal to mod Z4 minus Z1. Why? Because as they are the vertices of a square, all the sides are equal. The distance between these two complex numbers is just nothing but the length of each side. Of course, this is mod Z2 minus Z1, this is mod Z3 minus Z2, this is mod Z3 Z4 minus Z3, Z4 minus Z1. All of them are equal. Moreover, angle between two adjacent sides is 90, isn't it? Let me name them the points A, B, C, D. Here, AB is perpendicular to AD. AB is perpendicular to AD. Implies angle between AB and AD is 90. That we can measure as argument of Z4 minus Z1 by Z2 minus Z1 is equal to pi by 2. Is equal to pi by 2. Also, modulus of Z4 minus Z1 by Z2 minus Z1. How can it be? This is nothing but mod Z4 minus Z1 by mod Z2 minus Z1. You see, these are the lengths of the sides AD and AB. As they are the vertices of a square, those two sides are equal. Hence, this is 1. So that we say that mod Z4 minus Z1 by mod Z2 minus Z1 is 1. Let me call this entire complex number, say Z. Modulus of Z is 1 and amplitude of Z, that is argument of Z, is pi by 2. So that I say that Z4 minus Z1 by Z2 minus Z1 is equal to 1 into cos pi by 2 plus I sin pi by 2, or simply e power I pi by 2. Because if Z is a complex number, it can be expressed in mod amplitude form as mod Z into cos theta plus I sin theta. Here theta is pi by 2. So 1 into cos pi by 2 plus I sin pi by 2. Cos pi by 2 is 0 and I sin pi by 2 is 1. So this can be 1, implies Z4 minus Z1 is equal to Z2 minus Z1 into I. Now let us square it on both sides. What is going to happen? Z4 minus Z1 whole square plus Z2 minus Z1 whole square is equal to 0. How does it happen? If you square it on both sides, Z4 minus Z1 whole square is equal to I square into Z2 minus Z1 whole square, but I square is minus 1, hence it is minus of Z2 minus Z1 whole square. Bring it here so that we have Z4 minus Z1 whole square plus Z2 minus Z1 whole square is equal to 0. Now we could have made use of this perpendicularity. Absolutely in a similar fashion, you can use this perpendicularity also. that is Z4 minus Z3 by Z2 minus Z3 also has the argument pi by 2. Also has the argument pi by 2, and in a similar fashion that can be written is cos pi by 2 plus I sin pi by 2. Therefore, let me call this 1. In a similar fashion, what can we have? Similarly, Z4 minus Z3 whole square plus Z3 minus Z2 whole square is also 0. Call this 2. Now you expand each whole square involved in the equations 1 and 2 and add them. What are you going to get? 1 plus 2 implies Z1 square 2 times, Z2 square 2 times, Z3 square 2 times, Z4 square also occurs 2 times, so that we have 2 into Z1 square plus Z2 square plus Z3 square plus Z4 square, and in each whole square we have 2ab term, minus 2 Z4 Z1, minus 2 Z2 Z1, minus Z3 Z4, Z2 Z3, all of them we have. So if you get 2 out, minus, what do you have? Z1 Z2 minus Z2 Z3 minus Z3 Z4 minus Z4 Z1 is equal to 0, so that we shall be having the required one directly as Z1 square plus Z2 square plus Z3 square plus Z4 square is equal to Z1 Z2 plus Z2 Z3 plus Z3 Z4 plus Z4 Z1, which is directly available in the first option, that is option A is the correct option. We could have made use of the properties of a square. Between any two adjacent sides, the angle is 90, and of course all the sides are equal. By making use of those two things, we are able to get the answer Z1 square plus Z2 square plus Z3 square plus Z4 square is equal to Z1 Z2 plus Z2 Z3 plus Z3 Z4 plus Z4 Z1. That is option A is the correct option. Well, here it is very important to use this pi by 2. This is argument of Z4 minus Z1 by Z2 minus Z1 is just nothing but the angle between these two. As we could have noticed in the theoretical discussions itself, angle between those two can be written directly as this. We have known the argument. We have already had an idea about the modulus, that is length. As it is a square, it is 1, so that we have these two equations, and by adding which you are going to get the answer. Option A is the right option for that question. That's it. We now look at this second question, question number 2. In this question, Z1, Z2 and Z3 are the vertices of an isosceles right angle triangle. Of course, right angled at the vertex Z2. Then Z1 minus Z2 whole square plus Z3 minus Z2 whole square is equal to, first option 0, second option Z1 minus Z3 whole square, third option Z1 plus Z3 by 2 whole square, and the fourth option none. Let us observe the diagram. Let me assume the three vertices Z1, Z2, Z3 like that. It is an isosceles triangle, that is these two sides are equal and this angle is of course 90 degrees. From the diagram itself I can directly have that mod Z3 minus Z2 is equal to mod Z1 minus Z2, isn't it? Because it is isosceles. Not only that, this angle is 90. Oh, can you make use of that 90? Also, argument of Z1 minus Z2 by Z3 minus Z2, no doubt it is pi by 2. Is pi by 2. Therefore, not only that, modulus of Z1 minus Z2 by Z3 minus Z2 is equal to, modulus of that is mod Z1 minus Z2 by mod Z3 minus Z2, and from the diagram itself we see that these two are equal. They can be cancelled, leaving you 1. If you call this some Z, this is with modulus 1 and amplitude pi by 2. Therefore, what can you write? Therefore, Z1 minus Z2 by Z3 minus Z2 is equal to 1 into cos pi by 2 plus I sin pi by 2. I sin pi by 2. This is nothing but I. Cos pi by 2 is 0 and I sin pi by 2 is I. Sin pi by 2 is 1. Implies, what can you have? Z1 minus Z2 is equal to I into Z3 minus Z2. Again, you square it on both the sides. What are you going to have? Z1 minus Z2 whole square is equal to minus of Z3 minus Z2 whole square. Because, justly because I square is minus 1. So, if you bring that to the left hand side, what can you have? Z1 minus Z2 whole square plus Z3 minus Z2 whole square is absolutely 0, and it is given in the option A. So option A is the right option for this question. The next question is question number 3. Here capital C is equal to cos 2 pi by 7 plus cos 4 pi by 7 plus cos 8 pi by 7 plus, and capital S is equal to sin 2 pi by 7 plus sin 4 pi by 7 plus sin 8 pi by 7. Then he is giving us 4 options. He is discussing about the values of C and S. In the first option, that is option A, he is giving C is equal to half, and in the second option S is equal to half. Third option C is equal to root 7 by 2, and the fourth option is S is equal to root 7 by 2, which is correct. Let us examine. First of all, what is C? What is C? C is equal to cos 2 pi by 7 plus cos 4 pi by 7 plus cos 8 pi by 7. Cos 8 pi by 7. And so S. Again, S is equal to sin 2 pi by 7 plus sin 4 pi by 7 plus sin 8 pi by 7. Sin 8 pi by 7. Well, let me write C plus IS. What happens? This entire thing plus I into this entire thing. Again, I can split into 3 parts. That is cos 2 pi by 7 plus I sin 2 pi by 7 plus cos 4 pi by 7 plus I sin 4 pi by 7 plus cos 8 pi by 7 plus I sin 8 pi by 7. That is cis 2 pi by 7 plus cis 4 pi by 7 plus cis 8 pi by 7. Again, you can write it as e power I theta plus e power I into 2 theta plus e power I into 4 theta, where theta is equal to 2 pi by 7. As a matter of simplification only. As a matter of simplification only. Again, you can write this as a plus a square plus a power 4, where a is equal to e power I theta, where a is equal to e power I theta. Again, where a is equal to e power I theta. Next, therefore, we could have simplified C plus IS in the form a plus a square plus a power 4, where a is equal to e power I theta. You see, one more thing we can observe here, mod a is equal to simply 1, e power I theta is nothing but cos theta plus I sin theta. Its absolute value, its modulus is 1, cos square theta plus sin square theta, mod a is 1. Moreover, a power 7 is also 1. You can observe it very easily and carefully. What is a power 7? What is a power 7? E power I 7 theta. 7 theta means 7 into 2 pi by 7 is nothing but 2 pi. What is e power I 2 pi? Cos 2 pi plus I sin 2 pi is 1 plus I 0 is 1. So we'll be making use of these two things further. in the next steps we definitely use these. Well, so far what C plus IS is, we could have learnt. Now let me calculate what C minus IS is. A plus A square plus A power 4 bar. Why? Because it is C plus IS bar. There is nothing but A bar plus A bar square plus A bar power 4. A bar power 4. Here we can say one thing. A bar is equal to A bar by A. Can't you write like this? A bar by A. What is A bar? Mod A bar square. But mod A bar is 1. So mod A bar square is 1. Hence it is 1 by A. Again in the place of 1 you can have A power 7. A power 7 by A is A power 6. A power 6. In the place of A bar we can have A power 6 plus A bar square. A bar square. A bar square is here. A bar square, that is by A bar we mean A power 6. A bar square means A power 12. A power 12 is nothing but A power 7 into A power 5. That is A power 5. A power 5. Let me repeat it. Let me repeat it. What is A bar? A bar by A. But A bar is mod A bar square. Mod A bar square is 1. 1 by A. But in the place of 1 we have A power 7. A power 7 by A is A power 6. Okay, so by A bar we can replace A power 6. Well and good. What is A bar square? A power 6 whole square. What is A power 6 whole square? A power 12. A power 12 is A power 7 into A power 5. But it is A power 7? 1. Hence it is A power 5. Again, A bar power 4. That is A power 6 whole power 4. A power 24. A power 24 is nothing but A power 21 into A cube. A power 21 into A cube. A power 21 is 1. A power 7 whole cube. So the last thing is nothing but A cube. A power 6 plus A power 5 plus A cube. Well, this is C plus IS and that is C minus IS. Let us see what happens when you add them. Therefore, C plus IS plus C minus IS. We could have found C plus IS and C minus IS. Let us see what happens if you club them. C plus IS plus C minus IS gives you IS minus IS and plus IS will go away. This is actually A square, A power 4 are here. A cube, A power 5, A power 6 are here. Therefore, A plus A square plus A cube plus A power 4 plus A power 5 plus A power 6 are here. Well, what is the fate of LHS? IS and IS will go away, leaving you 2C is equal to, it is a GP, hence it is A into R power n minus 1 by R minus 1. But A into A power 6 is A power 7 minus A by A minus 1. You see, by A power 7 we can replace 1 because A power 7 is 1. We could have already noted it. Hence it is 1 minus A by A minus 1. 1 minus A by A minus 1. Therefore, 2C is equal to minus 1 implies C is equal to minus 1 by 2. Is it correct? Is it correct? In the first option C is equal to half is given and in the third option C is equal to root 7 by 2 is given. So it means that both the options are wrong. Therefore, it is not useful for us to get the value of C. Let us now concentrate on the value of S. How can it be obtained? If value of S can be obtained, then we can trace the answer from the two options B and D. Let us try. So far, we could have noted what C plus IS is and C minus IS is, by adding which we could get C, but in vain, because we have got C is equal to minus of, but it is not available among the options. So we have to try to get capital S. And to get S, We now multiply C plus IS and C minus IS. What is C plus IS? A plus A square plus A power 4. What is C minus IS? A power 6 plus A power 5 plus A cube. Let us see what happens in the product. Well, what is C plus IS into C minus IS? C square minus I square S square. But I square is again minus 1. Hence, left hand side here is C square plus S square is equal to, come on, multiply. A into A power 6, A power 7, that is 1. A into A power 5, A power 6, A into A cube, A power 4. A square into A power 6, A power 8. A power 8 means A power 7 into A power 1, that is A. A square into A power 5, A power 7, that is 1. A square into A cube, A power 5. A power 4 into A power 6, it is A power 10. A power 10 means A cube. A power 4 into A power 5, A power 9. A power 9 means A power 7 into A square. But A power 7 is 1, hence it is A square. And at last, A power 4 into A cube is again A power 7, that is 1. That is 1. Altogether, how many ones are here? 1 plus 1 plus 1, it is 3. And then, next, A plus A square plus A cube plus A power 4 plus A power 5 plus A power 6, all of them are available. Hence, this is 3 plus A into A power 6 minus 1 by A minus 1 as before. As before, it is correct. Again, A into A power 7. What is A into A power 7? A into A power 6, A power 7. A power 7 minus 1 by A minus 1 is again minus 1, that is 2. Since A into A power 6 minus 1 is equal to A power 7 minus 1 is equal to minus A is equal to 1 minus A. 1 minus A by minus 1 is minus 1. 3 minus 1 is 2. What is C square? What is C actually? Previously, we could have got that C is equal to minus half. C square is 1 by 4. 1 by 4 plus S square is equal to 2. So, at last, we have got S square is equal to 2 minus 1 by 4, that is 8 minus 1 by 4, that is 7 by 4. S square is equal to 7 by 4, hence S is equal to root 7 by 2. Is it available? Of course it is available. In the fourth option it is available. Hence S is equal to root 7 by 2 is the correct answer. Well, let us understand the plan of solving this question. We are given two expressions with capital C and capital S. C full of cosine values, S full of sine values. We have introduced I between them so that we have C plus I and C minus IS. By adding them and multiplying them, we are able to get both C and capital S also. Of course, C is equal to minus F. It is not available in the options, but S is equal to root 7 by 2 is available among the options. And the option D, that is the fourth option, S is equal to root 7 by 2 is the correct answer. Here, the crucial points to be kept in mind are A power 7 is equal to 1 and mod A is equal to 1. By noting them, we are able to have the answer directly. That's all the question. The question is, fourth question is, if Z1, Z2, Z3 are non-zero complex numbers representing the points A, B, C such that 2 by Z1 is equal to 1 by Z2 plus 1 by Z3, then he has given 4 options regarding the nature and position of the points A, B and C. In the first option, he says that A, B, C are collinear. And in the second option, A, B, C lie on the circle centered at origin. And the third option, O, A, B and C are concyclic. And the fourth option, none. Let us have a look over that. Let us observe the position of the points according to the data. Then only you will be able to decide which option is correct. Well, what is given first of all? 2 by Z1 is equal to 1 by Z2 plus 1 by Z3. Right? What is 2 by Z1? 1 by Z1 plus 1 by Z2 is equal to 1 by Z1 plus 1 by Z1 is equal to 1 by Z2 plus 1 by Z3. Therefore, 1 by Z1 minus 1 by Z2 is equal to 1 by Z3 minus 1 by Z1. Right? Therefore, Z2 minus Z1 by Z1 Z2 is equal to Z1 minus Z3 by Z3 Z1. Z3 Z1. From this we have Z3 minus Z1 by Z2 minus Z1 is equal to, ignoring Z1 here on both the sides, you have minus Z3 by Z2, right? Minus Z3 by Z2. There is a purpose of obtaining this one. This complex number gives us so many ideas. Look here. Oh, Z1, Z2, Z3. Imagine. From the last step, what can you see? Argument of Z3 minus Z1 by Z2 minus Z1 is equal to argument of minus Z3 by Z2. Am I right? Z3 minus Z1 by Z2 minus Z1 is minus Z3 by Z2 by Z2. This is argument of minus 1 by Z2 by Z3. This is equal to argument of minus 1 minus argument of Z2 by Z3. Z2 by Z3. Well, what is Z3 minus Z1 by Z2 minus Z1? Z3 minus Z1 by Z2 minus Z1. Is it not this angle? Therefore, what is argument of minus 1? What is minus 1? If you can express minus 1 in mod amplitude form, it is nothing but cos pi plus I sin pi. Hence, its argument is pi. Hence, this is pi minus, what is argument of Z2 by Z3? Angle between Z2 O Z3. Am I correct? This angle is nothing but argument of Z2 by Z3. Well, what is this argument? It is nothing but angle Z3, Z1, Z2. That is this particular angle. Well, you bring that angle this side. What is going to happen? Z3, Z1, Z2 plus angle Z2 O Z3 is equal to pi. Therefore, a pair of opposite angles in a quadrilateral, sum of opposite angles is 180. What does it mean? Sum of these angles is also 180. Why? Because this total sum of all the angles in a quadrilateral must be 360. This is 180. And sum of the opposite angles are supplementary. That is, Z2, Z1, Z3 form a cyclic quadrilateral. It does mean that all those points are concyclic. Hence, the right option is option C we have. What is the right option? C. We could have got by observing or calculating the arguments. By that procedure, we are able to have the angles particularly in a particular corner, that is in opposite angle. Some of the opposite angles is 180 we are able to have. Hence, it is a character of a cyclic quadrilateral. Hence, the points Z1, Z2, Z3 are concyclic. Option C is of course the right option for this question. We shall get ready ourselves to go through the next question, that is question number 5. In this question, if modulus of 2z minus 4 minus 2i is equal to mod z into sine of pi by 4 minus argument of z, then locus of z is an ellipse, a circle, a parabola, or pair of straight lines. Let us see what happens. Well, what is the condition given? Modulus of 2z minus 4 minus 2i is equal to mod z into sine of pi by 4 minus argument of z. That is given. Well, let me take z is equal to x plus iy is equal to r into cos theta plus I sin theta, where r is equal to mod z and theta is equal to tan inverse y by x according to the quadrant in which z lies, whatever it may be. What is the argument of z from this discussion? It is theta. What is modulus of z? Small r. Now let me use the condition. What do you mean by 2z? 2 into x plus iy minus 4 minus 2i is equal to, what is mod z? R into sine of pi by 4 minus theta. Why should you write theta? There argument of z has been given and argument of z is nothing but theta. Well, let us try to simplify this. Modulus of 2, let me get 2 out, so that x minus 2 plus I into y minus 1, isn't it? 2 into 2 I've got out as a common factor. 2, this is x minus 2 plus I into y minus 1. 2 is got out, isn't it? Is equal to r into sine of pi by 4 minus theta. What is that? Sine pi by 4 cos theta minus cos pi by 4 sin theta. That is sine pi by 4 cos theta minus cos pi by 4 sin theta. Cos pi by 4 sin theta. Well done. This is equal to 1 by root 2 into r cos theta minus r sin theta. Right? What is r cos theta? Is nothing but x, because x plus iy is equal to r cos theta plus I into r sin theta, isn't it? Therefore, in the place of r cos theta, we can write x 1 by root 2 into x minus y, isn't it? Therefore, by simplifying which, x minus 2 plus I into y minus 1 modulus is equal to x minus y by 2 root 2. By squaring which, you will be able to have x minus 2 whole square plus y minus 1 whole square is equal to x minus y whole square by 2 root 2 means 8. It is very clear to observe that it is an ellipse, of course, with the vertices 2, 1. Isn't it? Hence, it is surely an ellipse with option A as the correct option. What is the correct option? A is the correct option, because we can see that it is an ellipse. Now it is the time for us to go through the next question, that is question number 6. In this question, he has given cos alpha plus cos beta plus cos gamma is equal to 0 is equal to sin alpha plus sin beta plus sin gamma. Then the value of sin 3 alpha plus sin 3 beta plus sin 3 gamma by sin of alpha plus beta plus gamma is equal to. Option A is 0, option B is 1, option C is 2, and option D is 3. He is asking us. It is a famous, well-known question. From the basic level, it has been given. Let us trace the answer. First of all, what is the data? Cos alpha plus cos beta plus cos gamma is equal to 0 is equal to sin alpha plus sin beta plus sin gamma, isn't it? Sin gamma. Now, let me write A is equal to cos alpha plus I sin alpha. B is equal to cos beta plus I sin beta. and C is equal to cos gamma plus I sin gamma. If you add these three, what do you get? A plus B plus C is equal to cos alpha plus cos beta plus cos gamma is 0, plus sin alpha plus sin beta plus sin gamma into I is again 0, hence it is 0. As A plus B plus C is 0, you can be in a position to write that A cube plus B cube plus C cube is equal to 3ABC, right? By the by, what is A? It is nothing but cis alpha. It is nothing but cis beta. It is nothing but cis gamma. What is A cube? Cis alpha whole cube. What does it mean? Cis 3 alpha. Why is it so? By using de Moivre's theorem, a well-known and famous theorem. Absolutely in the similar fashion, what can you write in the place of B cube? Cis beta whole cube. That is cis 3 beta plus cis 3 beta. Again C cube cis 3 gamma is equal to 3 into A into B into C. What is that? Cis alpha into cis beta into cis gamma is just nothing but cis alpha plus beta plus gamma. Cis alpha plus beta plus gamma. Let us expand this. What is cis 3 alpha? Cos 3 alpha plus I sin 3 alpha, cos 3 beta plus I sin 3 beta, cos gamma plus I sin 3 gamma. So that we can write this as cos 3 alpha plus cos 3 beta plus cos 3 gamma plus I into sin 3 alpha plus sin 3 beta plus sin 3 gamma is equal to 3 into cos of alpha plus beta plus gamma plus I into sin of alpha plus beta plus gamma. Now, by equating the real parts and imaginary parts on both the sides, we shall be having sin 3 alpha plus sin 3 beta plus sin 3 gamma is equal to sin of 3 into sin of alpha plus beta plus gamma. Hence, the required ratio is sigma sin 3 alpha by sin alpha plus beta plus gamma is therefore equal to 3 is the right answer. Hence the answer is option D is the right answer, that is 3. That is the question. The next question before us is question number 7. In this question, he is giving us z as a complex number satisfying the equation z power 4 plus z cube plus 2z square plus z plus 1 is equal to 0. Z power 4 plus z cube plus 2z square plus z plus 1 is equal to 0. Then the set of all possible values of mod z is set of all possible values of mod z. What is that? In the first option, that is option A, set containing 1 and 2. Second option, set containing singleton 1, set containing only one element 1. And option C, set containing 1, 2 and 3. And option D, set containing 1, 2, 3, 4. Let us observe the given equation. What is the given equation? Z power 4 plus z cube plus z square, 2z square plus z plus 1 is equal to 0. If you can factorize that, it is an easy matter to split this into two parts, x square plus z square plus 1 into z square plus z plus 1 is equal to 0. And it is an easy matter to look at z is equal to plus or minus I omega and omega square are the possible values, that is the roots of this equation. It is very easy to say, and whatever might be the value of z among these four, omega square, of course, are the complex cube roots of unity. Whatever might be the value, mod z is always 1. What are the possible values of z? These are the possible values of z. What are the possible values of mod z? 1 only, because mod I is 1, mod minus I is 1, mod omega is 1, mod omega square is 1. Hence mod z is 1 in any case. Therefore, the only possible value of mod z is one only, that is the singleton set containing 1. Option B is the correct answer for this question. Option B. The next question is question number 8. Let A, B and C represent the complex numbers Z1, Z2 and Z3 in the organ plane. If the circumcenter of the triangle ABC is at origin, he has given that the circumcenter is at origin, then the complex number corresponding to the orthocenter is, he is giving us 4 options, that is 1 by 4 into Z1 plus Z2 plus Z3, 1 by 3 into Z1 plus Z2 plus Z3, half into Z1 plus Z2 plus Z3, and the last one Z1 plus Z2 plus Z3. These are the options. Well, here it is an important matter to discuss with. Circumcenter is given at origin and he is asking about orthocenter. There is a good friend of these two centers, that is centroid. For any triangle, centroid, orthocenter and circumcenter are always collinear. Centroid divides the centers, line joining orthocenter and circumcenter in the ratio 1:2 internally, whereas the orthocenter divides the segment joining circumcenter and centroid in the ratio 2:3 externally. That is to be used here. So, in order to answer this question, you must be knowing the relation between circumcenter, orthocenter and centroid of a triangle, which are surely collinear. Here orthocenter is this is the question, which is the heroine of the topic. Second one. And circumcenter is at origin. Circumcenter is the origin, that is 0 plus I 0. And centroid, what is the centroid? Centroid is equal to, we know the vertices are Z1, Z2 and Z3, hence the centroid is Z1 plus Z2 plus Z3 by 3. Z1 plus Z2 plus Z3 by 3. Two things are known. One thing is unknown. Here it is the right time for us to know the relation between them. Actually speaking, if you can take the reference of a right angle triangle, circumcenter will be at the midpoint of the hypotenuse, centroid will be in the middle of the triangle, orthocenter will be at the vertex, at one of the vertices at which the right angle is observed. Hence, in general, centroid lies in the middle. It divides, of course, the ratio 1:2. But here we require orthocenter. It divides the center, the line joining circumcenter and centroid in the ratio 2:3. Externally, of course. In the ratio externally. If you can apply, it's very easy matter to look at that the answer is Z1 plus Z2 plus Z3. Therefore, the answer is option D. That is Z1 plus Z2 plus Z3 is the required orthocenter. Let us look at the next question. That is question number 9. Z is equal to X plus I, Y is a given complex number. And he is giving us a condition regarding Z. Modulus of 2Z minus I by Z plus 1 is M. That does not represent a circle. Please notice it. It does not represent a circle. For what values of M it happens? For what values of M it happens? He is inquiring of. The first option, that is option A, is M is equal to half. Second option is M is equal to 1. Third option is M is equal to 2. And the fourth option is M is equal to 3. Let us see. What is the condition first of all? What is the condition? Modulus of 2Z minus I by Z plus 1 is equal to M. Let me divide both the sides by 2. It can become Z minus half I by Z plus 1 is equal to M by 2. Isn't it? I have divided both the sides but not numerator and denominator. Well, this represents a circle if m by 2 not equal to 1. Does not represent a circle if m by 2 is equal to 1. Have you followed? Suppose there is a point z minus a by z minus b is equal to 1. Suppose if you have, what is going to happen? Modulus of z minus a is equal to modulus of z minus b. In the earlier stages itself, we could have recollected different loci. If there is a locus which satisfies that condition, then z is nothing but the perpendicular bisector of the segment joining the two complex numbers a and b. Yes. So it's not a circle. You may have to recollect that point. If you want to have this locus not to represent a circle, then this m by 2 is equal to 1 or not equal to 1. It must be 1. It must be 1. Does not represent a circle if m by 2 is equal to 1, that is m is equal to 2. Is it available? Of course, it is a very simple conceptual question. What is the concept you could have understood here? You must recollect that concept. If mod z minus a by z minus b is equal to 1, then it cannot be a circle because it is just nothing but the perpendicular bisector of the segment joining a and b and the organoid plane. It's not a circle and we want it. In the present question, we do not want it as a circle. So, this must be 1, hence the value of m is 2. It is available in the third option, that is option C is the correct option. Now we look at the next question, that is question number 10. He is giving that alpha, beta, gamma are the roots of the equation x cube minus 3x square plus 3x plus 7 is equal to 0 and omega is a cube root of unity. Then alpha minus 1 by beta minus 1 plus beta minus 1 by gamma minus 1 plus gamma minus 1 by alpha minus 1 is equal to how much? The first option is 3 by omega, second option is omega square, the third option, that is option C, is 2 omega square, and the last option, that is option D, is 3 omega. How can we link alpha, beta, gamma with omega? Let us observe. The first thing, what is the given equation? The given equation is x cube minus 3x square plus 3x plus 7 is equal to 0. Therefore, x cube minus 3x square plus 3x minus 1 plus 8 is equal to 0. Observe these terms by recollecting binomial theorem. It's just nothing but x minus 1 whole cube plus 8 is equal to 0. Plus 8 is equal to 0. Therefore, x minus 1 whole cube is equal to minus 2 whole cube. X minus 1 whole plus 8, if it goes that side, it becomes minus 8, and I am writing it to be not minus 8 but minus 2 whole cube. So that we have x minus 1 by minus 2 whole cube is equal to 1. Now let me take this as some y. We have got y cube is equal to 1. Therefore, the roots of y are nothing but the cube roots of unity. Therefore, x minus 1 by minus 2 is equal to 1 omega square are the roots. Now, let us see. If x minus 1 by minus 2 is equal to 1, then x minus 1 is equal to minus 2, x is equal to minus 1. I name it to be minus 1. Sorry, alpha. Next, if x minus 1 by minus 2 is equal to omega, x minus 1 is equal to minus 2 omega, x is equal to 1 minus 2 omega. Let me write this as beta. And the last possibility, x minus 1 by minus 2 is equal to omega square. X minus 1 by minus 2 is equal to omega square. Therefore, x minus 1 is equal to minus 2 omega square. X is equal to 1 minus 2 omega square. Let me write it as some gamma. Gamma is equal to 1 minus 2 omega square. Successful. We are able to write alpha, beta and gamma in terms of omegas. Alpha is minus 1, beta is 1 minus 2 omega and gamma is 1 minus 2 omega square. We have got all the three values corresponding to alpha, beta and gamma. They are ready here. To estimate the required, we shall be making use of these values. What is the required expression? Let us now calculate it. Well, what do we want actually? Alpha minus 1 by beta minus 1 plus beta minus 1 by gamma minus 1 plus gamma minus 1 by alpha minus 1 is equal to, this is alpha. What is alpha minus 1? Minus 2. This is beta. What is beta minus 1? Minus 2 omega. Plus, what is beta minus 1? Just now we have seen minus 2 omega. What is gamma minus 1? This is gamma. What is gamma minus 1? Minus 2 omega square. Minus 2 omega square. What is gamma minus 1? Minus 2 omega square. What is alpha minus 1? It is minus 2. Now, this is 1 by omega plus 1 by omega plus omega square. What is 1 by omega? No, 1 by omega. Let us see the options first of all. This can be written as omega square, omega square, omega square. 3 omega square we must have, but omega square, 3 omega square is not available among the options. So do not get disturbed. Don't disturb this 1 by omega. 1 by omega plus 1 by omega. You can write omega square is also 1 by omega. Why? Omega square is equal to omega square by 1 is equal to omega square by omega cube is equal to 1 by omega. Am I correct? Of course. You can write omega square as 1 by omega. 1 by omega plus 1 by omega plus 1 by omega. Again, this is 3 by omega. Hence, what is the right option available? The first option, that is option A, is the correct answer. That is 3 by omega is the correct answer. The main principle or the main activity here in answering this question is you must be able to split the given equation x cube minus 3x square plus 3x plus 7 is equal to 0 as x minus 1 whole cube plus 8 is equal to 0. Thereby it was made possible to get omegas and omega squares into the fray so that we are able to estimate the required in terms of omegas and omega squares and could collect the answer as 3 by omega. That is the first option. Option A is the correct answer. That is the question.